All right, so P.4, we're reviewing trig. Um, this handout up here, you should have on Canvas. For those of you, well, no, you should have it on Canvas. For those of you that are in person, I may have handed this out if I remembered. But you should have this handout. It should be linked on Canvas if nothing else. You don't actually need to practice filling it out until you can complete it in 5 minutes. We're just going to use it as a aid in what we're doing with trig. So a little bit of trig review. First off, I'm going to review the graphs because I feel like if you know basically what the graphs look like, it's going to help you kind of visualize the rest of what's going on. So the graph of sine, we're going to do sine, cosine, and tangent. I'm not, those are the ones I'm going to concentrate on. And graphing with this tablet is a challenge, but we're going to do it anyway. Sine and cosine both are trapped between 1 and -1. That is an important thing for you to know. The values that they give back, the y values, their range is -1 to 1. Sine and cosine both are periodic. They're waves. So they have a wavelength, essentially. We call it the period. Sine starts at the origin. I mean, it goes on forever each way. I'm just doing one wavelength. Typically, we think of it as starting at the origin, goes up, goes down, and then the period or the wavelength would end again on the x-axis. So it looks like this. Sine is odd. It has origin symmetry. So obviously, on the other side goes like this. And this wavelength or the period is 2 pi. Okay, it is 0 halfway in between at pi, and then it has this maximum. It hits 1 at pi over 2, and it hits -1 at 3 pi over 2. All right, so it kind of splits that into fourths, that period into fourths. So that's sine. Y equals cosine x. So again, trapped between 1 and -1, unless there's a transformation. We'll talk about that in a second. Cosine typically starts, well, it doesn't typically, it always starts at 1. So the wave of cosine looks a little bit different. Basically, cosine and sine are the same. They're just shifted over a little bit. So cosine starts at 1, goes down to -1, and comes back up to 1 and stops. And this is one wavelength or one period, which is 2 pi. Halfway in between is pi. So at pi, it's -1. At 2 pi and 0, it's 1. And then these zeros split it into fourths, split 0 to 2 pi into fourths. So that's pi over 2 and 3 pi over 2. So that's what the graphs look like for that. And then tangent is the last graph that we're going to look at just real quickly. Tangent tangent is sine over cosine. That's one of the identities you should know. All right. So if you don't know it, you should know it. You need to know it, really. Like, really, you need to know that. But so tangent is going to be undefined anytime cosine is 0. So cosine is 0 at any odd multiple of pi over 2. So it's going to have a vertical asymptote because denominator being 0 is going to give us a vertical asymptote at pi over 2, 3 pi over 2. Usually we kind of say, okay, pi over 2 and -pi over 2. But it's any odd multiple, so it's going to have repeated. Tangent is not a wave, but it is periodic, so it repeats itself. So, all those odd multiples of pi over 2, it's going to have an asymptote at. Tangent is going to be 0 when sine is 0, which is at 0, pi, 2 pi, etc. So it's going to be 0 at 0. And what happens is it kind of looks like x cubed. So we got that. And then we'd have a 0 here at pi. And it would just repeat itself. I can't draw it very well, but it kind of looks like x cubed, except for it has vertical asymptotes there. So that's your tangent graph. A little bit on the transformations. This again is helpful for kind of visualizing what the graph looks like and knowing some of the properties. These are all the possible transformations except for a reflection. I don't have a negative in here anywhere, but you could have a reflection. A is typically called the amplitude of the wave. It is how high and low it goes. So instead of thinking of it as a vertical stretch or shrink, I think of it as the height or depth of the wave. So if you had 2 sine, this would go up to 2 and -2. All right, that's how it would change. B affects the period. The period for sine and cosine, by the way, please don't call them sin and cos. The period for sine and cosine is 2 pi divided by b. For tangent, and again, don't call it tan, it's tangent, is pi over b, because the period for tangent is pi. All right, each of these little asymptotes are pi apart. And then obviously C and D are shifts up and sideways, up, down, and right, left. Okay. For your unit circle and for doing things in radians, so a lot of times people are confused about radians because you're going 0 to 2 pi instead of 0 to 360. So we're going to talk about the unit circle just a little bit, actually a lot. So the unit circle is a circle with a radius of 1, and the worksheet deals with that, but I want to just draw something out right here. So we think of it as a circle with a radius of 1. Right, circle is 360 degrees. People get really confused about the radian measures. All right, on the axes, we think of on the x-axis as being angle 0. We also think of it as being angle 2 pi. This is not 0 divided by 2 pi, it's 0 or 2 pi. All right, so if your initial side of your angle is the positive x-axis, the terminal side kind of swings around. We think of it as swinging around the circle. So if your initial and terminal side are both the x-axis, either at 0 or you've gone a full circle, which is 2 pi. All right, for the rest of the axes, I think of it like fractions of pi. Like when I read pi over 2, I mean, I say pi over 2, but I think of it as 1/2 pi. All right, so on a half circle is pi. And then I think, okay, this splits that in half. So if I divide pi by 2, I get 1/2 pi. And then this makes 3/2 pi. So that helps me kind of orient myself on the unit circle. Some important angles to know. I mean, obviously you should know that pi over 2 is 90, pi is 180 because you're thinking of, half circle. And 3 pi over 2 is a little bit less important, but 270. And then 2 pi is 360. The other angles that you really should know off of the top of your head, which ones they are, is pi over 6 is 30 degrees. The 6 and the 3 kind of interchange. Pi over 3 is 60 degrees. And pi over 4 is not 90, 45 degrees. All right, those are the important ones, and those are important because of kind of reference angles, and those are the ones that we know the trig functions for exactly, or we should know the trig functions for exactly. All right, so we're going to go back up to this unit circle, and I'm going to zoom in so we can start kind of filling this out. I'm going to put in some of the angle measures. So this is pi over 2. This is your pi, 3 pi over 2. This is 0, and, oh, they have the 2 pi down here. There we go. This is going to be your 30-degree angle, so that's pi over 6, pi over 4, pi over 3. And then you can fill in the rest of these, but I think of them, okay, so if I'm thinking about where the angle is, so let's say 5 pi over 6, I think of that as 5/6 pi. That is less than a whole pi because pi is 6/6. So 5/6 pi is going to be right here. Okay, so to figure out where on the unit circle the angle is, I compare the fractions. All right, so if I'm thinking 7/4 pi, 7/4 is closer to 2 than it is to 1. So 7/4 is going to be your pi over 4 down here. Okay, so that's kind of how I think of the unit circle, all right, with being able to place the angles on the unit circle. So I'm going to go ahead and fill in these other angles. This is 3 pi over 4 because that's 3/4 pi. This would be 5 pi over 4 because that's 5/4, a little bigger than 1. Let's see, this is going to be the pi over 6, so it's going to be 7 pi over 6. And this is going to be 4 pi over 3. And then this is going to be 5 pi over 3 and 11 pi over 6. All right, so when I'm doing the problems, and we'll get to doing the problems in a little bit, but when I'm doing the problems, I think of what fraction of pi it is and kind of try to place it on the unit circle like that. All right, if you're familiar with trig at all, you know the choices for sine and cosine typically, I need to go back a little bit, but are square root of 2 over 2, square root of 3 over 2, or 1/2. and they could be plus or minuses. All right, so which one is which? That's what we're going to get to. I forgot. On the unit circle, x is cosine of your angle. The x coordinate is cosine and the y coordinate is sine. That's why I know Mags doesn't like the unit circle and memorizing things, but I think that's helpful to know is your x coordinate is cosine and your y coordinate is sine. So if the radius of the circle is 1, this point on the x-axis then is 1, 0. So that means the cosine of 0 is 1 and the sine of 0 is 0. Same for 2 pi since they're the same angle. If this is a radius of 1 and this is on the y-axis, this point then is 0, 1. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1. You really need to know the zeros and ones as far as pi over 2 and pi. You should like know those so you don't have to figure them out. The coordinates of this point are negative 1, 0. So the cosine of pi is negative 1. The sine of pi is 0. And then 3 pi over 2 is 0, negative 1. So those are important ones to know. Okay, so let's go back to this. These are your options, really, for all of these. So which one goes with which angle, and which one is cosine, and which one is sine? The easy one is square root of 2 over 2. That always goes with a pi over 4. All right, any of your over 4s. Okay, so if it has a denominator of 4, your sine and cosine are both square root of 2 over 2. It just might be negative. All right, so we know this is square root of 2 over 2, and this is square root of 2 over 2. All right, all of the pi over 4s are going to be that way. It's just one of them is negative. Well, which one is negative? It depends on the quadrant you're in. In first quadrant, x and y are both positive. In second quadrant, x is negative, y is positive. So you're going to have negative square root of 2 over 2 and positive square root of 2 over 2. In third quadrant, both are negative, x and y. So negative square root of 2 over 2, negative square root of 2 over 2. In fourth quadrant, x is positive, y is negative. So positive square root of 2 over 2, negative square root of 2 over 2. All right, now for the 30 and 60, one of them, sine or cosine, one of them is square root of 3 over 2, and the other one is 1/2. How I remember which one is which, and there's different ways. Some people use their hands, and you can say, okay, this is, let me hold it up right. This is, I forget. There's a thing with your hand that you can do. We can talk about it in class. You can do 30, 60, 90 right triangles to help you remember which one is which. That's what I used to do. You can also think of it in terms of lengths. If you square root of 3 over 2 is bigger than 1/2, so when you look at this coordinate, this x coordinate of this point is going to be bigger than the y coordinate. So this one is square root of 3 over 2, and this one is 1/2. For this point, the y coordinate is bigger than the x coordinate. So this is going to be 1/2, and this is going to be square root of 3 over 2. And then you have the negatives on the other side, all right, on the other parts of the unit circle. So that's how that helps me do the problems without a calculator, by kind of thinking about, okay, for pi over 3, that's 60. Is the x coordinate going to be bigger than the y coordinate, or the y coordinate going to be bigger than the x coordinate? And we can talk about this a little bit more in class. And in the next video, I'm going to do a bunch of examples using this. So we'll kind of come back to that in the next video, because this one's getting a little long and I want to take a break.